And good afternoon to everyone. It's a great pleasure to be here today to talk about space, in particular Space Connect, as the event has been organized also by alumni of École Polytechnique. So just to show that this matters to the school, matters to the ecosystem of the school. And I'm glad also to be here to talk about space because space is under revolution. We know it has been obviously of interest for decades, interest because of research, obviously understanding the universe, but also increasingly interesting for geopolitical reasons. Security, sovereignty is at the core of the space topics, and obviously economic. In addition to this, as we see that telecommunication, agriculture, a lot of industries depend on space and innovation. So at the core of research, sovereignty, and economic topics, École Polytechnique has always been part of the space history and is accelerating on that front, trying to push the frontier along these different dimensions. And I would like to share with you today some of the advances we are making on the research front, on the education front, and on the innovation front, as obviously that's the mission. And in a domain where today not only the states are continuing to invest into space, but also the private industry is investing, global action is going on, it's very important to continue to be at the frontier and to push the topics forward. So if I focus first on research, we have 23 laboratories at École Polytechnique. Some of them are here today. Some of the professors are also present at Space Connect. And we have been pushing in many dimensions. And I would just highlight, obviously, a few to show where research is going. If I take a few examples, if it works, yes. Basically, the frontier of the space domain is along several dimensions. The first one is obviously to observing the Earth from the space. And this is what the LMD is doing, the Dynamic Meteor Laboratory, trying to understand more and more how atmosphere is going. And we know climate change is obviously at the core of the big challenges society is facing. And this laboratory is continuing, obviously, to push the understanding through LIDARs, either on Earth, on satellites, and understanding better where the climate is going and impacting, obviously, some of the actions we are doing. Another topic, you may have already talked about that, but it's part of what also Gérard Mourou has been pushing. The Nobel Prize in Physics is around cleaning up the space. It's obviously more than 20,000 debris basically being in space, threatening some of the observation or the mission that we can have in space. And the laser is of utility here through the high power that has been developed, through the new techniques. Can we get some melting point on the debris and getting them out of the orbit? And the laboratory here is a Lully laboratory that is focusing with the XCAN project on getting some solutions to this. Third area is to continue, I would say, something that has been going on, but continuing to understand the solar system. And this understanding, the sun, the planets, through spectroscopy instruments. And here the LPP, the Plasma Physics Laboratory, has been pushing in that direction with new ideas, new perspectives along this dimension. Third area, obviously, that space is focusing on is to understanding the deep space, obviously beyond the solar system, the universe, how to detect basically the messages that are arriving on Earth. And here the Laboratoire Le Prince Ringuet, based on the name of a famous alumnus, famous professor that is working obviously among many things about cosmic rays, is continuing to push to understand what is coming on Earth, what do we know about the universe, and it's part, in particular, of one of the big projects called the HESS project. You may know about, obviously, trying to, based on telescopes in the Namibian desert, to understand better the inflow of gamma rays and what we know about the high energy rays coming in. Fourth or fifth element is to reproduce the astrophysical phenomenon. And this also is where the laser, that has been at the core of many of the laboratories, play a role, trying to reproduce the extreme conditions, obviously, that we think are part of the planets around the universe, trying to reproduce the extreme condition of temperature, of pressure, and understanding better what's going on in these conditions, in particular around some of the planets, gaseous planets, or magnetic field of gaseous planets. 6 is to talk about the, and I'm sure you heard about Trust Me this morning, I think, is reaching the space via the plasma propulsion. How do we continue to innovate along that dimension? What is at the core of the reactors, plasma reactors, and so on. Two other elements I would highlight. Two other laboratories are involved. One is the Omega laboratory, which is working on the chips, the microcircuit, to basically get radiation resistance, low power consumption, to make sure we can put the microchip on space or instruments going into the space. And the other one is the CEMAP, the Applied Mass Laboratory, working also on high performance computing to support the modeling that obviously is going on through all these instruments, detectors, trying to model what's going on in space. As you can see, many dimensions of the new space, many frontiers that are pushed by a lot of the laboratories. And obviously, we are very happy and pleased to see this activity going on and this contribution to research. But beyond research, obviously, and I would like to move to that, research also is helping on education. And it has been a second topic of our mission, a second mission of École Polytechnique we have been developing. And I think Professor Chabert is in the room, and he has been at the core of developing the next frontier on the spatial education or education around space. We have been developing a specialization curricula to try to make sure people can deepen their understanding through a couple of things. On one side, the high scientific modules linked to the research I just talked about, but also a lot of learning by doing approach with many projects with the researchers, with the students, with industrial players. And two examples are on this page. One is the CubeSat that was done 4 or 5 years ago. And the other one is IronSat, which is going on right now with dozens of students working on this topic with the objective of obviously sending it to the space in a few years. And this is in the context of the Student Space Center of École Polytechnique that was developed by Professor Chabert and a few other researchers, and with the support also, and I would like to highlight that, of industrial players like Thales Arena Space, Ariane Espace Group. Obviously, the CNES also is involved, and trying to get a great dynamic of linking the research to the education and also to the entrepreneurship. And this is also an area that I think is very important also to highlight, is that, and this is maybe more recent, the last 5 to 10 years, innovation has been accelerating. New space has been obviously accelerating, but also innovation at École Polytechnique has been accelerating through the combination of these different forces between research, between education, and between also industrial players. And just to highlight a few examples, you heard about, I think, Trust Me with Anne Annesland, a researcher from the LPP, the Plasma Physics Laboratory, who through her research basically led to innovation, acceleration at the SAT on the Plateau de Saclay, and now highly successful development of the business. Another example is ExoTrail in similar topics of propulsion, but more broadly also sustainable development in space, developed by some alumni of École Polytechnique, also accelerated through the DRICE, the incubator and the accelerator of École Polytechnique, and now also developing very well. Another example is Share My Space, which is focused on the surveillance system of the space to get a sustainable development. So here are a few examples. I think there are many others. We had a few other startups in the DRICE laboratory during the last year. One was WeRock, which is on the integrated circuit to try to get hardened circuits that can go into the space. And another one, Space Sense, that was also focusing on agriculture, how to provide information to agriculture to improve basically the management, in any case, the economic impact space can provide through agriculture. As I said, the interest today is I think space is facing several challenges, obviously continuing on research to understand the universe, on geopolitics to understand also how sovereignty can be sustained. And we can see here that Europe is taking care of some of these aspects. Thierry Breton, the commissioner, announced $1 billion in innovation fund to make sure We continue to innovate as European, facing also some of the other, basically, countries' investment. And we also have the billionaires that are investing also in that context. So the ecosystem is changing, and universities and École polytechnique in particular want to play a role in linking the research to the alumni, to the industry, and to the further innovation going forward. So maybe in conclusion, or as a next step, I would say beyond what we are doing today, which I shared in a rapid fashion today, we are continuing obviously to invest into the topic. We have been building the Institut Polytechnique de Paris, which is bringing the 5 schools together around École Polytechnique. We have 4 other schools that came over the past years, and the 5 of us together are building, I would say, an institute to really push forward of science, technology, and space is definitely part, major application, major domain. We want to continue to push on and linking the laboratories I mentioned from École Polytechnique with the digital laboratories of Telecom, the system laboratories of ENSTA, or the statistics of ENSAE. We get obviously more capabilities, and we know that solving the space challenges requires multidisciplinarity. We are also hosting at École Polytechnique the CubeSat Symposium in November, which is to continue to push, to network on a European basis with other students, to bring students around this topic. Will be a competition at that time. And so we are very proud of that, and I hope at least some of you will be joining that symposium. And finally, we're also part of a European network. We are part of Eurotech universities with our friends at TUM in Munich, DTU in Copenhagen, TU Eindhoven, Technion, and EPFL in Lausanne. And the 6 of us are basically developing what we call also the Eurotech University to really continue to push education, research around engineering, and providing solutions to the most important issues society is facing. And as I mentioned before, space is definitely a critical issue I think we need to address, and society is facing for all the topics I was mentioning, or all the reasons. And so we will continue both in Palaiseau, on the Plateau de Saclay, but in partnership with our European colleagues to make sure we provide solutions, we continue to push the research, to continue to nurture education, and obviously draw or drive innovation going forward. So I can just conclude by saying that continuing to push the frontiers in space in a context where we have major transformation going on in the space arena is at the core of what we are going to continue, and École Polytechnique is committed to push research, education, and innovation in the space industry. Thank you for your attention.